publisher, even an author, to enrich my publications so that a machine can understand its structure. So how many people here are familiar with researchblogging.org? One person, so I'll explain. So researchblogging.org is an aggregator for blogs that mention scientific articles. Right? So you essentially publish your blog and it has a citation to the article in a particular metadata format, and that means that research blogging can aggregate that web page. And this is an example of one of the blog posts that I found. This is 3 ways concepts maps help you learn. And I like this because I used to work on, when I was younger, concept mapping software. So I said, that's pretty cool. I looked at this a couple days ago. And at the bottom of this blog post, there's citations to a couple articles. And so what I did was I said, well, this is just something that's there. How much machine understandable metadata is already in there? What's available? What could a machine easily get a hold of? And then what could you do with it? Right? So what's inside this paper? Lots of metadata, actually. It's quite cool. So at the top, you have microformats. How many people are aware of what microformats are? So microformats are one way of adding structured data to web pages. And I told this was a technical plenary, so I didn't mind putting up code, right? So at the top, and that's kind of metadata communicating things about who authored it, their time, date. Some more metadata, right? This is called open URL coins, and if you ever see Z3988, that means there's a formal citation in metadata that a computer can understand. This is marked up inside this web page. And actually, there's even more metadata in this particular web page using even other different standards. Right? So there's Open Graph Protocol, Facebook Open Graph Protocol. Have people heard of this? So this is what fuels the like button. So every time you hit like, right, on a page that supports like, it's using metadata expressed in Open Graph Protocol. Right? And so what is this metadata here? Well, it tells you, again, the author, it tells you the title, it tells you that it's in English, right, which is important if you're analyzing it. What else does it tell you? It tells you a description, which is nice. How many people are familiar with RDF? Oh, this is pretty cool. I rarely go to places where more people know RDF than the Facebook Open Graph Protocol, so that's awesome. Right? So they have even some, and this is not even like cool, this is not even RDFA, this is like old school RDF, right? This is RDF XML, right? So this is really cool. That's all of this metadata in one single blog post. And this is not uncommon to find on the web. And there are lots of tools to support this very simple kind of semantics in web pages. And so you can start doing things with this. One thing is this is an overview of some of the metadata in that page from a Google product called Structured Data Viewer. So you can Google Structured Data Viewer, and if you put a web page into it, just a URL, it will extract all the machine processable metadata that it can find, right? And so these are some of the things that it extracted from that blog post about a piece of research. And this is pretty simple stuff, right? It's not very complicated, but it's super useful, and we'll get to that in a second. One thing that this doesn't just have to be for a blog post, right? So I'll call out PeerJ. So PeerJ is a fairly new journal with kind of a funky business model. And one thing about PeerJ, one reason I like them, and I tried to publish with them, but they don't accept computer science articles. But anyway, so this has really cool metadata in it. In fact, it has all the stuff you saw before. Open Graph Protocol, it has also has some open, I don't know if it has open coins. It may have open coins. It's got Dublin core stuff. It's got lots and lots of semantic representations in it. And that's pretty cool. So this is for an actual journal paper. It tells you the authors, the editors, all this kind of information. All available. And by the way, this is one of the reasons that open access is so important. Because I can write, as a computer scientist, a way, or you can go download crawlers that can get access to all this metadata. And if it's behind a firewall or behind a paywall, it makes it that much harder. Right, to get access to this information, to build interesting applications. So now let's talk about what you can do with all this fairly simple metadata. Well, you can throw it through a processor, like this one is Ini23, and this is RDF that we've extracted from that web page, and I can go and write queries over this. So I can write queries like, find me the authors, find me the date, find me authors who wrote blogs about in English, right? And because I can extract this, I can mix it with other data, right? And so suddenly it's much more computer processable than just that text on the page. So I can do more stuff. I can aggregate it. Right? So I can take this and I can build this research blogging aggregator, and I can make these sorts of cool looking citations in my blog post. So here's the one we were talking about, right? So this is the summary they got out of it. They got the nice little icon, and then they got the 2 citations and they laid it out with a direct link to the paper. So now this is aggregating all these blog posts about citations because of this semantic representation. I can create rich snippets in Google, right? So Google will now display the name and a bit more in the search results about the article. That's pretty cool, right? So if you're running an open access repository, if you're running a journal, this is the kind of thing you want to show up in Google. You can do more cool stuff with this kind of metadata. So this is New York Times, and Twitter offers similar metadata to the Open Graph Protocol, and actually PeerJ supports the metadata that Twitter requires, and these are like 3 lines in your code. 3 lines. And what you get is this ability to have these kind of what they call cards. So again, with the description, with sorts of images, all associated with your tweet, right? So another completely way to filter and expose content. And you can imagine aggregating this in other fashions, creating different forms of scholarly communication that link back to the original article. Again, powered by metadata. So this is an example from PeerJ. I think my followers were kind of freaked out when I was publishing about molecular modeling and pharmacology, but I just wanted to show you an example of, okay, now we're surfacing more information in my Twitter feed about this article because of that metadata. Some more stuff you can do just with this simple metadata. This is a project from Montana State University, and they want to host their, essentially their videos for their entire university on YouTube. Because they don't want to have the kind of storage capacity, they don't want to have to deal with that sort of video style infrastructure. YouTube already has it. But on the other hand, they want to make an aggregate view of the kinds of video content they have, right? And again, here, they use schema.org metadata. So it's really simple. You can just stick this in a web page. You say, okay, this item information, it has a name, it has a description, it has a thumbnail, it has a duration for your video. And then they can aggregate that together, put it on their own site while using YouTube as the storage center. And that's what metadata lets you do. So another kind of application, video aggregation. And finally, how many people have heard of pin interest? Okay, almost as much as RDF. That's even cooler. So pin interest, this is science.